Welcome back to the next video. We have now on pillars of object-oriented programming. We know object-oriented programming was developed to bridge the gap between human and the computer and to understand the pillars of OOPS, which are actually abstraction, encapsulation, inheritance, and polymorphism. We have to understand few basic concepts of OOPS before we get into more details. Okay, so we know that object oriented was developed to interact freely, easily, and to write the code in such a way that they are very easy to understand and we can reuse the code, right? So the coding, writing computer program that makes it easier to organize and reuse the code was the concept behind object-oriented programming. And it involves creating objects that represent things in real world, like we have car or a person or furniture or animals that we have seen here also. So these objects can be used to build more complex systems and make the code easier to understand and maintain, right? So object oriented has some basic concepts that help develop write better code. So developers can write better codes using these concepts, and we have to look them one by one. So let's have a look. The main concepts 11 actually: class, objects, encapsulation, abstraction, inheritance, polymorphism. These are the pillars also: method overloading, method overriding, association, composition, and aggregation. The four pillars, we'll be looking at them separately also and see the code also behind them. But first of all, let's understand the basic concepts and then we'll go into the details also. So class is a collection of similar entities. We have seen that earlier also. And it defines the structure and behavior of an object or an entity, you can say, by that class. And it also encapsulates data, or you can say attributes or properties and functions, like the methods of what we in object oriented we call them methods, we don't call them functions, and that operate on the data. So it encapsulates, protects that. Talk about encapsulation. Now classes, they are used to define data types, and they can be called a user defined data types also. And each object created from a class is actually an instance of that class. So each object created from a class is an instance of that class that belongs to the class basically. So what is an object? An object is an instance of a class, and it is a concrete representation or a blueprint to define a class, or which is defined by the class. So it is a blueprint basically. Objects have a state and behavior, that is the values, attributes, methods, yeah, and the on which operations are performed. So they have state and behavior also. Now comes encapsulation. Encapsulation, basically, it is the concept of building data and methods that operate on data with a single unit, that is single class, allows objects internal state only through defined methods, and provides better control and data protection. Basically, this is for encapsulating, that is protecting the local data. And like suppose I want to protect my variables and all, so that is used for protecting. Encapsulation helps in protecting the local variables. But for a bigger concept, we have abstraction. Abstraction would protect the entire class. Like suppose I want to go in rain outside, and it is raining. I would be either using an umbrella or a raincoat, right? So what I'm doing is I'm protecting my entire body. So if I'm protecting my entire body, it is abstraction. And in computer concepts, abstraction, you can say, is hiding something from the user which is not required. Okay. Abstraction, encapsulation, inheritance, they are all actually examples of inheritance. We inherit properties, values from our parents, father, forefather, and so on. Behavior we are getting. Same way a class inherits properties from its derived class. The base class, the derived class. We'll be talking about the base class and the derived classes later. But these are the basic concepts we have to understand before we go into the deeper details with the example. Polymorphism, poly basically means more than one. Physm means activities. So more than one activity at the same time, if you are going to handle, we call it polymorphism. So it is basically then the ability of objects to take take on multiple forms. So it is the ability of the objects to take on multiple forms and allows single interface to represent different types of classes or objects of objects. So there are two types of polymorphism. So first of all, one is the compile time and the other is runtime. That is, we have method overloading and method overriding. Compile time, when we run the code for the first time, that is compile time. And when the code is running, during that time, whatever happens is your runtime. But we have two more concepts here, method overloading and method overriding, and we'll be talking about that also. Method overloading. It is basically a compile time polymorphism, that is a static polymorphism, where multiple methods with the same name, there will be more than one method with the same name, but with different parameters and different data types. So that is method. You're having method, let's say we have a sum, but with sum, one is your integer, one is your float, or it can be something else also. So if we have multiple methods with different data types, that is overloading your methods. So appropriate method to execute, it depends on based on the type of argument we are passing to it and the object we create. And in the object, with the object, we whatever type of data we pass, that particular method would be called. So we do it like overloading is done frequently to have polymorphism in the codes. So method overriding is also there. This is runtime basically during the execution of the code. If something like this happens, we call it overriding. So basically, it occurs when a derived class provide a specific implementation for a method that is already defined the base class. If we have a method already defined and we just want to use it again during the runtime, that is overriding that method. And but it can be with different parameters also. The overriding method in the derived class takes procedure over the base class. So methods, when called on an object of the derived class, then we call it overriding. So overriding and overloading, there's a basic concept of compile time and runtime. We'll be seeing them in detail when we are working on it. We'll be seeing through the examples, so the concept will be much clearer that time. For now, we just have to understand the concept. Then we have association. It represents a relation between two or more classes, like which actually indicates like one class is how it is related to the object of another class. It can be one to one, one to many, many to one relationship. So these relationship can be like that. Then we have composition. Composition basically is a special form of association only, and the lifetime of the associated object is controlled by the containing objects. That is the difference. And when a containing object is destroyed, if I destroy the containing object, the containing object are also the contained objects are also destroyed. Whatever is contained is also destroyed. Like if I have a matchbox and I set it on fire, whatever inside it will also be destroyed. Okay, so that is what composition is. Then aggregation. The last concept, aggregation, is actually another form of association where the lifetime of associated object is basically independent of containing object's lifetime. So whatever the object's lifetime is, it is independent of that. Now it represents actually the whole part of relationship, not the limited part. It represents the entire part of relationship, and the contained object can exist independently of the container. That is, they can be independent of the container. Like we have a car and we have an engine can be independent also. So we will be seeing them in detail. So these concepts basically help the a programming language like C++, Java, and C Sharp, and more like these languages for the foundation, for the basic concepts. Now, let's see the principles also for object-oriented programming. These are again very important part of coding. So we have to understand this also. So basically, object-oriented, is guided by several principles, like the concepts, which help developer design and implement robust, flexible, and maintainable software. That means it has to be working in different conditions. It should be very flexible and which we can easily maintain. That is the concept of object-oriented. That is reusable code should be there. So these principles often referred to as, we call them solid principle, SOLID, and which was introduced by Robert C. Martin, and it is widely used in the industry. Solid stands for single responsibility principle. One is SRP, then open close principle, OCP, Liskov substitution principle, LSP. Then we have interface segregation principle, ISP, and then we have dependency inversion principle, that is DIP. Let us look at them. Small introduction would be given right now. Then we'll be going in details, right? Now, this principle states that a single responsibility principle. You can see from the name itself, only one person is responsible, or one thing is responsible to do some certain thing. So this states that class should have only one reason to change. That is, it should not have more than one responsibility or task to fulfill. Now, when we adhere to SRP, classes become more focused on less and less likely to have unintended side effects when changes are made, because it is handling only one particular job. And also, it promotes maintainability because it reduces the risk of errors. So once I know one task is assigned to this and it is this class doing this particular task, so I can easily maintain that and handle the errors also. Then we have OCP, that is open closed principle. This suggests that class should be open to extension, that is, it can be extended, but closed for modification. Can be extended, cannot be modified. This means that the behavior of a class can be extended or inherited, or through inheritance, interfaces, or plugins, but cannot be modified its existing code. You cannot modify the existing code, but it can be inherited, and using interfaces or plugins or inheritance, actually get the concept but cannot modify it. Then we have OCP also actually encourages creation of flexible, again, and reusable code. That is the basic concept of object oriented programming, so that it can easily adapt to a new requirement. Okay. Then Liskov substitution principle, that means it must be substituting something. It actually states that when we have a base class and a superclass, then superclass should be replaceable with objects of its subclass. Okay? Base class, subclass, without affecting the correctness of the program. That means superclass should be replaceable. We can replace the superclass without affecting the core. That is, without affecting the subclass. Or we can say that, in other words, we can say that subclass should honor the contract of their superclass and not introduce unexpected behavior or violate the invariance. Okay, so subclass should work and and should honor the contract of the superclass. So superclass should be can be replaced without affecting the code. And when we adhere to LSP, it actually shows that a program behaves correctly when using polymorphism and inheritance. So when we are using polymorphism and inheritance, this LSP helps in maintaining the code and behavior of the code, as superclass can be replaced, but subclass will still maintain the right. Let us come to interface segregation principle, that is ISP. ISP actually it emphasizes, tells that class should not be forced to implement interfaces or it does not use fully. That means if I'm calling something and I'm not using it, then I should not be calling it, and it should not be forced. A class should not be forced to call it. If I'm not using it, leave it. So instead of creating large monolithic interfaces, which are actually a burden to the code, the ISP encourages breaking them down into smaller and more specific. So suppose I'm calling an interface which is huge, but I'm just using one or two parameters for that. So I should not be calling all of that. So it's better that you break it. So this way we can have the classes which can choose the interface they need and prevent unnecessary dependencies. It should not depend on the entire thing. Just need one thing, I should get that only. Okay. Then we have DIP, that is dependency inversion principle. So this is a high level module, and uh, here it should not depend on low level modules. That is, the high level modules should not depend on the low level modules, but both should depend on abstraction, that is interfaces or abstract classes. So a DIP principle says that high level modules should not depend on the low level. Okay, but they should depend on abstractions. Abstraction is something which is hidden from the, so it encourages of dependency injection, that is it encourages the use of, so what DIP is doing, it encourages the use of dependency injection and inversion of control to decouple classes and make them more independent and testable. So this way, DIP would help the classes to be independent and testable. That means when the classes are separate, they are independent, we can test them easily also. So they should be testable and so when we apply or rely on abstraction, the code becomes more flexible and easier to maintain, because something is written hidden from the user. We know that this is done. This we don't require it anymore. We abstract that. So now the dependency is lesser. Okay. Now these are the few concepts and principles which we have to keep in mind while understanding the basic concepts of object-oriented programming. This helps the programmers to program in a better way and to understand their code also, because the basic concept is to make the code reusable, maintainable, flexible, and robust. Okay. So in the next video, we will be talking the classes and objects, and then we'll be going ahead with the pillars. Again, that is abstraction, encapsulation, inheritance, polymorphism, and aggregation, and all we'll be doing in detail with sample codes. So see you the next session. Have a nice day. Thank you.